walkthrough of the cube calculator or box calculator project. So looking at the design, I have a Windows form with a label, simply gives the title. Then I started with another label for my image, and I imported the image that was in Canvas into the image property, and then added the label for side A, or the height, and the text box that I named txt side A. And I aligned the text to the right and put in 8 as the default there. Then I have another label, side B, or the width, a text box txt side B, also aligned to the right, default value of 5. Label text of side C, or the length. Another text box named txt side C, aligned to the right, value of 10. We have our btn calculate. And then here are labels for volume, total surface, circumference 1, circumference 2, circumference 3. I color-coded the circumference 1, 2, and this should be 3. And that should be 3 purple. I color-coded the 3 text boxes for the orange, blue, and purple to coordinate with basically the strings going around our cube. So by circumference, I mean if we put a string around the 4 sides of the cube, how long would that string need to be? So these are named txt volume, txt surface, txt circumference 1, txt circumference 2, and txt circumference 3. Let's take a look at the calculate button code. That's where all of our code resides. And so we have our private void btn calculate underscore click. Our object is sender, event args e. That was all done by default when I double clicked. So I created a bunch of variables all on one line. They're all double types: side A, side B, side C, volume, surface, circum1, circum2, and circum3, comma separated, and a semicolon at the end. Side A is going to equal txt side A dot text. So the text property of that text box names txt side A. That's a string. I'm going to use double.parse and place that inside the parentheses for that parse method to convert the text to a double value, a numeric value that contains decimals. Do the same thing for side B and side C, getting the values of the text properties of those 2 text boxes and converting them to double. The volume is going to equal side A times side B times side C. Simple math. Surface, we want the area of each side, and there's 6 sides, so there'll be 3 sides that are duplicated. So I have side A times side B, side A times side C, and side B times side C. That gives me 3 sides. Multiply that by 2. That's going to give me the surface area. How much cardboard would it take to create this box? The string going around the first circumference is side A plus side B. Now there's 4 sides, so it'd be side A plus side B plus side A plus side B. Or I just simply made it a little bit simpler, side A plus side B multiplied by 2. Do the same thing for circumference 2, side B times side C times 2. Circumference 3 is side A plus side C times 2. Now notice these are in parentheses, so order of precedence is going to do the addition first before it does the multiplication. If you don't put the parentheses here, it's going to multiply side B and add that to side A, and you're only going to get 3 of the 4 sides. The volume, we're going to display in our text box named txt volume, so we're going to set the text property equal to the volume. Now that's a double value. I need to convert that to a string, so using .toString. And I want to show 2 decimal places. So inside the parentheses, we can put in quotes N2. That means a number with 2 decimal places. Doing the same thing for txt surface.text, setting as the surface.toString, and then our 3 txt circumferences, setting those to the 3 values of our circumference variables, and using toString, converting those or displaying those to 2 decimals. If we change the value of side A, and we're going to have this do all 3 of our different input labels, we want to clear the results. So we set the text property of each one of those 5 output labels to just a null string. Now how do we set that up to do that same thing for the others? Well, if we go back to our design, I'm going to bring up my properties, and looking at the events, we can see that text changed on this method is txt side A text changed. If we look at side B, we can do the same thing, and then for side C, it's also the same one. You can choose with the drop down here what handler you want to have the text changed event process. So all three of these share that same one. Even though it's named txt side A underscore text changed, it applies to side B and side C. Let's watch this run. So I'm going to take these values of 8, 5, and 10, say calculate. And so our volume is 400, 8 times 5 times 10. 40 times 10 is 400. The surface area, we've got 8 times 5 is 40. 5 times 10 is 50, that's 90. And then 8 times 10 is another 80, that's 170. We multiply that by 2 and we get 340. The circumference of the orange string going around is going to be 5 plus 8 plus 5 plus 8, that's 26. The blue is going to be 5 plus 10 plus 5 plus 10, that's 30. And the purple is going to be 8 plus 10 plus 8 plus 10, and that's going to give us 36. In our case, we simply did two sides and multiplied it by 2 in our calculation. Everything seems to work. That's my code review. If you just jumped into this video, you can see all the videos from the C# Xamarin Programming Cohort playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.